Hello, today we'll learn how to find an intermediate point M between two endpoints P and Q. Now, if we turn our attention to the second question, you notice this midpoint question, which is very popular in almost all the geometry textbooks. And I want you to realize that finding a midpoint is nothing but a very special case of this more general weighted average concept that you don't have to memorize the formula for the midpoint. I hope you realize that by the end of this lesson. Now, for the midpoint, since midpoint is an average and it's in the middle, we use the same weight, 0.5 each, for both P and Q. And then I worked it out so that you see the midpoint 5, 4 for the point M. Now, if we move up to this first question again here, which is more general and more complicated, what I want you to realize is that since M is 3 times as far from Q as from P, you notice that the weight we need to use is a quarter because M is a quarter of the distance from P to Q. So we will use the weight quarter for the point P because the point M is closer to P, meaning further away from Q, and Q has a weaker gravity pull, so to speak. So let's use equals quarter. I will use fraction for accuracy. Of course, in this case, it really doesn't matter whether you use fraction or decimal, but just let me use fraction here. Okay, so equals, we will use 3/4 for the point P. And I programmed it ahead so that those two weights will add up to 1. Otherwise, you don't have the right setup to begin with. Okay, let's continue to find the x-coordinate of M. This is how you find the x-coordinate of M. First, equals. Now, we need to find a linear combination of x-coordinates and weights. So what you do is x-coordinate of P times 0.75 plus x-coordinate of Q times 0.25. There we go. Then x-coordinate we find is 3. Now, for the same process, we will do P equals 2 times weight 0.75 plus y-coordinate of Q, which is 6, times 0.25. And there we go. We find the point 3, 3. Now, which is a general case of this special midpoint question. Now, what if we change the question like this? We change the problem so that M is not 3 times, but twice as far from Q as from P. Then what you will do is change the weight for Q to be 1/3. Again, Q is a weaker planet because point M is closer to P, so we use 1/3 for Q and 2/3 for P. Again, the weights add up to 1, and here we go. Of course, we get decimals, but if you use a fractional notation, point M should be 3 and 2/3, and y coordinate of the point M should be 3 and 1/3. Okay, now I hope you realize that this midpoint question is nothing but a very special case where the two weights happen to be the same and we get the midpoint, which is the average right in the middle. So hopefully from now on, without memorizing the formula, you'll be able to find any intermediate points between any two given endpoints. All right, that's it for today. Thank you.